Good morning, stellar traveler. As the gentle hum of our ship fills the void around us, we find ourselves at the precipice of a momentous task. Can you feel the anticipation? Just 48 hours away from the mothership, and we're ramping up for our final challenge, repairing the docking gear. This isn't just any repair. It's a symphony of all we've learned, all the tools we've acquainted ourselves with, converging for one grand purpose. Let's ensure that when we touch down, we do so with more grace than a dying star. The horizon of home beckons, and we have much to do. Today's Task Explorer is both intricate and comprehensive. Remember the code from our previous day's adventure? We'll need that, along with the symphony of our passive buzzer and the visual allure of our OLED. And don't forget the 4x4 keypad, which will serve as the bridge between our will and the majestic mechanism of our landing gear. Yesterday, we ensured our dip switches are safety compliant. So, once all three are flipped, that very keypad will be our instrument to both deploy and retract our landing system. The rest of our tools will come center stage tomorrow. Let's glide through this with the precision of a starship pilot, shall we? Let's move on to how we're actually going to code this. We need a way to figure out if we have flipped all three of the dip switches and passed our necessary safety checks. We can probably do this by checking all of the switches' states and only continuing once they've been activated. Next, we need to add today's additional logic for our 4x4 keypad. We will be using that to deploy our landing gear. It doesn't necessarily matter which button makes it deploy, so let's just use A. That should work. Let's review the cached instructional material from your mission resources and give it a quick test.
Hello everybody and welcome back to day 28 of the Lost in Space code explanations. Today, again, I'm starting with an empty sketch, and the reason why is because I want to make sure that you guys set this up correctly. Since we're going to be using a header file, and this file is going to be including all of our bitmaps, we want to make sure that we get this right. When we see our code on day 28, you'll notice we have the following. We have obviously the wiring diagram, we have the code that we normally see, but you'll notice down below we also have an additional piece of code, which is our landing underscore gear underscore bitmaps.h. And the way we can create this properly is we can obviously copy our first code here by going up here, hitting the copy, and when we go up to the next bit, now we've copied this, we can hit verify, and oh, look at that! You got an error here. And if you're getting this error, it's because you need to go up to the top right, hit new tab, and type in landing underscore gear underscore bitmaps.h. Hit enter, make sure you copy the code from that other file, and make sure you paste it all in here. If you go and you hit verify now, you'll notice that nothing breaks because it has the bitmaps and it knows where it's at. So that's perfect. If you're getting that error, please make sure you obviously include that in the IDE. Obviously, at the very top, we have a lot of the same stuff we've done every other day. I can just delete a lot of it, boop, boop, get rid of that, and it will still function the same because Arduino.h is automatically included, assuming you're using the Arduino IDE. If I go down here, we have all the libraries we used, we have this, and we obviously just included, just now, the landing gear bitmaps, make sure that was done correctly. Finally, we have an array of pointers, just like yesterday. If you remember for the switches, we have it for the lander bitmaps. And this is going to create a nice, cool, smooth animation showing the lander extending and bringing back its gears. Down here below, we have the calculate how many gear bitmaps we have in total. So if we ever want to add more bitmaps to this animation, we can. And you're free to do so. And that's just what this does. So we have gear bitmap count. We could just assume that it's going to be 4, but if you ever want to add more yourself, this is going to make it so you can without any issues whatsoever. Finally, we have an enumerator gear state. In this, we have the following. We have a total of 3 different states that the gears can be in for our landing gear. 0 is going to be where we're considered idle. Lowering is going to be equal to 1. And we're going to set raising is equal to -1. And we're going to have this thing called index. And index is going to be what keeps track of what state that we are in. The reason why that's important is because later on in the code we'll have a potential issue, and that's that if somebody were to raise the landing gear before we were fully ready to land tomorrow, we got to make sure that we are able to cancel all of the landing thing at any point. If we accidentally raise the landing gear, we don't obviously want to land at that point, so we have an ability to back out. Down here below we have the 4-digit 7-segment display setup that we're just going to call the bitmap number display, which basically is going to tell us what bitmap that we're displaying. Finally, we have the defined pins for our dip switches. Again, we're using analog because of the fact that we won't have enough on day 29 otherwise. And finally, we're introducing our 4x4 keypad button matrix. Now, the total amount that we're going to be using on day 29 is going to be strange though. You'll notice that we are only going to be using rows 1, 2, and 3, and we will be using all 4 columns, which means the very bottom row of our 4x4 keypad is not going to be used. That is going to be completely unused, but luckily the way we have our setup for our keypad in our library and how awesome it is we can do that. We don't need to have it plugged in. We can use 10, 11, 12, 13, and 9, 8, 7. The reason we're doing this, and we didn't have 6. Normally we would have had something like 6 here before, but we don't, because we don't need that last row. So it makes it a lot easier for us. Finally, we have the lander controls. We have the controls known as unused, and then obviously raise and lower gear. Today, we're just focusing on raise and lower gear. All the rest of them right now are unused, and going tomorrow on day 29, we'll use these, this, and also this, but we won't, technically this will probably end up being unused tomorrow, and this will be unused tomorrow. Tomorrow we'll be focusing on the direction of our ship and making sure that we're actually able to control it once the landers are disengaged. But here we have the raise and lower gear for our landing gear. Right now, most of it is unused, so we just focus on these two here. In the top right corner, we down here have the keypad lander controls, where we are going to obviously create the keypad, and we're calling it lander controls. So the 7-segment display was called the bitmap number display, and if you ever want to call any of the nice keypad function, we can use the lander controls and call whatever we want to from there. Finally, we have the approach state. Now, here is some of the states that our code will be running through. We'll be building on this later to perform the actual approach flight and landing in the mothership bay. So this isn't going to be used too heavy right now, but this will be used tomorrow in much more detail. Starting in setup, we have a serial begin 9600. Technically, this doesn't do anything. We don't technically print anything, so if you accidentally deleted this, it technically wouldn't break anything. Down here below, we have the following. We have the bitmap number display we're going to set up. We're going to configure that. The dip switch, just like yesterday. The lander display, just like yesterday. We're also setting the text font, which is something we didn't do yesterday. We're defining how the max height, the text height is calculated. And we're setting the Y coordinate to be the top of the tallest character, so that whenever we print it, we want it to obviously print from the top down instead of the bottom up, so that it will display on the thing. So if we did 0, 0, it will be showing on the display instead of kind of off the display. Down here we have the loop function, which is where the most of our logic for today is going. And let me tell you, there's quite a bit of it. So I'm going to be going through this kind of briefly, otherwise I'm going to be here kind of forever. A lot of this logic down here is mostly going to be displaying the graphics on our display, and I will primarily, instead of going into every single bit of calculation, I will be primarily going over a higher level of it. We have the first 3 of these. We have the thrust lever, the systems lever, and the confirmation lever for our dip switch. This is going to be using a lot of logic from the previous day. So if, depending on what state it's in, we will be displaying a certain type of bitmap on the screen or changing up the text that's on the screen. We're going to start with the index being 0. As you recall, I mentioned up here, we're going to be keeping track of what state we're in, the gear state, by using an index counter. That counter is going to be here, the current gear bitmap index. When we have the approach state, meaning we're approaching mothership, we're going to be going into approach initialization. And when we're in the initial gear state, the initial gear state we're going to be just setting to idle, which is going to be 0. Going down here below, we have the obviously very first initial state, which is going to be the approach initialization state. So if switch approach state, depending on what state we're in, again up here we have initialization, pre-flight, and final. Initialization is going to be the very first case, and if we're in this state, and only if we're in this state, we're going to assume that all switches are off now and we're ready for the pre-flight. And that means that we're going to switch our new state going forward to the approach pre-flight. Assuming that all of them are off, we're going to go into pre-flight. If we're now in pre-flight, all switches are off to begin with. If the chance happens that through this version of the loop, all of the levers are switched to on, that means that we're going to be going into the approach final state, and we're going to switch to the final state once all 3 are on. Finally, this is the most complicated state because there's just so much more stuff in a lot of this. If we are in the approach final state, we're going to get the lander controls.get key. This is where we're going to be able to press on our keypad to raise and lower the landing gear. If we want to lower the gear, we will current gear bitmap index, we're going to lower the gear, and we're going to set the gear state to gear lowering. What this means is that since we're in the gear lowering state, we have another whole bit of case statements down here, which says if it's lowering, we want it to display the graphic, and we want it to show the animation of the gear lowering on the OLED display. And then obviously we want it to continue and break after that. Otherwise, we have the raise gear state. So if it was lowered and we're going to raise it up from there, we want to show the gear raising, which is essentially that same animation but in reverse. Because we specified our gear states as either 0, 1, or -1, we can change bitmaps by simply adding the gear state to our current gear bitmap index. That makes it really easy. So if we want to lower it, we can just, subtract 1. And if we want to add it, if we want to switch to the other state, we can +1, etc. Makes it really easy for just basic logical math computations to make that work. If the gear animation is completed, that means that the index is either 0 or whatever. Then we can change our gear to the idle state here, assuming that the animation is completed. Finally, here's all the logic using the first page, next page, all these other methods to actually show those animations on the display. This is all this stuff here. We have all of the logic here that simply says if you have switch 1 on, switch 2 off, switch 3 on, whatever. We want to tell what we actually have on and what we don't have on. This is all the logic to do that here. We have the Y offsets to show where we want to put it on screen. We have obviously the X offset is just 0. We have the text we want to display at the top. And then finally we have the final display functionality here, which is just simply going to display once everything is all done and ready to go. We also have the liftoff. This is just a helper function that just takes whatever the liftoff state we're in, and it just simply says init or pre-flight. So if we're initialization, we'll say init, and if we're in the pre-flight case, we're going to say pre-flight, and that's something that we can then put on our OLED display a little bit easier than the case that we have here. So it just gives us text to work with that we can then use to work. Finally, we have the drawString function that we're using. That is another helper function that is used for on the display as well, just to display any string we want to on our OLED at a specific X and Y coordinate, and that's it. That is the bulk of day 28. We don't have currently anything for controlling our ship to get to the mothership, and we also don't have anything for what happens when we do get to the end of the mothership, confirmation of success or failure if we landed successfully, because that is coming tomorrow. And I look forward to seeing you then. See you on the last day tomorrow, and day 29. Safe travels, and your journey is almost at an end.
Welcome to the day 28 wiring example video. Today we'll take the next step in building up our landing system. We're almost finished, but we still have some components and functions to add before we're ready for the grand finale. Our additions today will allow us to visualize and control the status of our vehicle's landing gear. Now, last time, our dip switches and OLED display were hooked up in testing mode, but today they'll be giving us real-time control and feedback on the landing system. Most of this is being accomplished using exactly the same wiring and hardware that we used on day 27, and it's brought over then unmodified. However, the one big addition today is our reintroduction of the push-button keypad, which here we'll be using for landing gear deployment and retraction. Quickly reviewing our setup here, all the power and the ground connections are exactly the same as last time. So you can review day 27 if there's anything there that's not clear. Likewise, all the display data lines and the switch logic connections remain just the same. Now, we're finally using those Hero digital pins that we set aside last time, and we're using those to connect to our keypad using an 8-conductor ribbon cable. Counting here from bottom to top on the keypad, our 8 keypad pins are connected through this ribbon cable to Hero pins 6 through 13, and those should correspond to what you see in your software sketch. That pretty much covers all the modifications to the hardware for today. So with that review complete, we're ready to go ahead and run our day 28 sketch to verify our setup and operation up to this point. Note that just as on day 27, we have a new set of landing gear display bitmaps that are coming in through an external file. So make sure you've included the file landinggearbitmaps.h in the folder with your sketch before trying to upload and run it. I've done that already, so let's go ahead and try it. So we'll go over to the IDE and we'll begin the upload of our sketch. It'll take a few moments here for it to compile and upload. And we're just about there. Okay, so we can see that we started with all of our switches in the off position, and our status indicator here on the OLED verifies that we have all 3 of our switches in the off position, and we're in the countdown pre-flight condition. Now, before I go any further, I just want to point out that if you've looked at the software sketch for today, you'll have noticed that we are using 2 of the buttons on our keypad for landing gear control. The upper right-hand button, A, here's a little reminder of how we've mapped those buttons. Button A in the upper right-hand corner will be used to deploy the landing gear. And if we need to pull the landing gear back up, button B, just below A, will be the one that we'll use for that. Okay. So let's go ahead and run through a little rehearsal here and pretend like this is an actual approach and landing sequence. So first thing I'm going to do is I'm going to sequentially enable each one of our dip switches. So switch number 1, going to the on position, and we can see that we have an on condition for thrusters. Next, we'll go to switch number 2. Place it in the on position. And so we have a second on. Finally, we'll confirm. And when we press the third button, when we throw the third switch, this should put us into readiness mode. And so now you can see that we've successfully gotten through the preparatory phase, and we're now ready to test landing gear deploy. So when it is time to deploy the landing gear, we should be hitting button number A, button designated A here. And when we do so, we can see landing gears come down. And if we want to reverse that and pull the landing gear back up, button A does that for us. And we can repeat that if necessary. If I press A again, it doesn't have any effect because the landing gear are already down. I can pull them back up with B. So, everything seems to check out correctly. We're just one more rather big step away from being ready for arrival and docking. So, we'll see you then for the big day 29.
Explorer, as we sail through the vast expanse of space, our monolithic mothership beckons in the distance. Our docking gear stands ready, like a faithful guardian ensuring our safe descent. We're on the cusp of completing a journey few could even imagine, let alone accomplish. Rest and rejuvenate. The final approach awaits us in less than a day. Tomorrow, we return home. Good night, and dream of the familiar sights and sounds awaiting us.